Okay, hi everybody. Welcome to our regularly scheduled multi-tenancy working group. Today we have a pretty packed agenda. So Lockie is here from the steering committee to give us an update on some changes, I think, to how they're overseeing the various SIGs and working groups. And then we are going to have a curated conversation about CRDs and multi-tenancy. And then I think we have the team on from our last meeting to take any questions about their multi-tenant Kubernetes solution. So Lockie, if you'd like to take it away.
Wonderful. Thank you, Tasha. Hello, everybody in Working Group Multi-Tenancy. My name is Lachlan Evenson, and I representing Kubernetes Steering today. This conversation is mainly for the leads of this working group, but however, everybody will be involved in this conversation. So as you can see on the agenda, there was a mail sent out about a week ago introducing the concept of annual reports, and it's Steering's goal that as Kubernetes is getting larger and larger, that we want to create scalable ways to have reporting process. So we've introduced this concept of annual reports because previously all working groups and SIGs were required to actually go and provide quarterly updates at the community meeting. So we're trying to figure out new ways to make this process more scalable. And as such, we've introduced this concept of annual reports. So this is a way for the community to see how working groups and SIGs are going, and steering also to have a finger on the pulse of where we can help assist these different teams and processes within the Kubernetes community. So I think the main point I wanted to get across today is there is a link there to the mailing list. If you take a look at that link, you can go down to the bottom and you'll actually see the process as defined of what we're trying to do. So all this to say is there's a template that you need to go through, and we're asking each working group to actually take a lead on getting that done within the next 30 to 60 days. And we're just starting with working groups. So I just wanted to initiate the conversation with this working group. The other thing is I'm actually the liaison on behalf of steering to this working group. So I'm here to help you through the process. So I don't want to take too much time in your meeting because you do have a packed agenda, but I just wanted to introduce that concept. And who needs to be involved in that annual reports process? We're asking the leads of the working group, obviously, but we don't want to limit it to that. Anybody as part of this working group can be involved in the creation of that annual report. And the idea is that we give that back out to the community so they can see what this working group is doing, how things are functioning, and that can be a mark in time for how things are progressing. If I may, I added one more agenda item and then I'll give you back the rest of the time. We've also we're going to send out a mail in an effort to make more of take a more active role in creating an inclusive community. We're actually asking the leads to attend the Linux Foundation unconscious bias training. We're asking every lead in the Kubernetes community, whether they're technical leads or leads of things like working groups or SIGs, to participate in that. So I've added a link there. If you have already taken it, please feel free to go there. I know it's Sanjeev and Tasha who lead this working group. Please go and attend that because we want to make sure that we're creating forum and educating folks on how to use inclusive language to all our community members. So with that, I'll take a moment to answer any questions, but I see this as an ongoing conversation. And if you have anything or need anything from steering, feel free to ping me and at me. I'm at Lockie83 in Kubernetes Slack. But thank you very much for the time. Are there any questions?
Yeah. If anyone has any questions, definitely pipe up. I took the Linux BIOS training a while ago, and it's actually pretty fun. And at the time, they gave you a free jacket for completing it, but I'm not sure if they're going to scale that.
Yeah, absolutely. So I did it recently as well as part of being on steering. It's a fantastic, it takes about 30 minutes. It's completely online and digital. And even, you know, it's a course designed around, even if you're speaking at events like KubeCon, on how to use inclusive language and even confront your own unconscious bias. So I wouldn't limit it to anybody's welcome to take it. It's free. We're just requiring that the leads of the communities must take it within 30 days. If there are no further questions, I'll pass it back to you, Tasha. Thank you for the time and thanks for having me.
Yeah, thanks. Thanks for coming. Cool. Okay, yeah, and if anyone has any further questions, feel free to ping me or Lockie. Yeah, cool. So our next agenda item was going to be talking about multi-tenancy and CRDs. And let's see where. Did we have our discussion leader on the call today? I'm not sure if I see him. Because if not, we can jump to the next topic. Okay, so did anyone want to kick off that conversation? Because I think it was Rodolfo, but I don't see Rodolfo on the call right now. So if you want, we can just talk about Arktos, or I know a bunch of other people were chatting about multi-tenancy and CRDs on the mailing list. So if anyone wants to kind of jump in with some thoughts, we can do that as well.
Is Rodolfo available on Slack? I can try to ping him and see if he's there.
I'll see. Let's see.
He might be on the other link, given that a couple of people have had some problems with it.
Okay, I'll ping him, but
Okay. I know what I was.
I think he will miss today's meeting, so maybe we can postpone it for next week, please.
Okay.
Sorry,
Yeah.
oh, I couldn't hear you.
Yeah, what I was saying is maybe push it to next week, please. I think he will not able to join today.
I see.
Yeah, it doesn't look like he's online, but I pinged him. So if I hear back, you know, we can always switch. Cool. So let's see. The only other topic that we had was if people had questions about our presentation last week about Arktos, and I know that we didn't actually finish the Arktos, the entire Arktos deck. So if people have any questions or the Arktos team wants to finish their presentation, we've got time if that's something you'd like to do.
Yeah, I think this is Xiaoning. I think last time we finished the deck, pretty much of the deck, and but we didn't have enough time to discuss lots of details. Today sounds like we have some time. If you guys have any question regarding the multi-tenancy Arktos, I would love to we have a discussion.
Yeah, Xiaoning, I think that'll be useful. If you don't mind, just to sort of just refresh us, could you share the first couple? Could you share the first
Sure,
couple
no problem.
slides from your deck, and then we'll.
Yeah, let me open the deck. Can someone give me the permission? I'm disabled for sharing.
Yeah, let me.
So Daniel is asking on the chat, could anyone do an overview of the proposed multi-tenancy architecture project? So Daniel, there isn't like a single multi-tenancy architecture. We've got a few different projects that are sort of supported by this group, and you know, the wikis have more details on these. So Daniel, it's not just one unified multi-tenancy architecture. There's 2 or 3 different projects. Or you want it specifically on Arktos? Okay, so I think that's what Xiaoning is going to say right now. He had a.
Actually, I sent the link to the deck in the mail list. So if you guys are interested, feel free to check out. The deck is online. What slides do you guys want to?
You want to do 10 minutes as a quick refresher for those that might have been not on the last call?
Sure. Yeah, I can kind of quickly walk through some key ideas in this work.
And just as a note, the entire recorded presentation from last week is on YouTube too. So you can check out our YouTube channel and watch the entire in-depth presentation for anyone who missed it.
Okay, thank you. So I will quickly walk through the key points in the Arktos multi-tenancy. Basically, Arktos itself, it's a project, open source project derived from Kubernetes, and we added some core design enhancements. One of them is the multi-tenancy. Our multi-tenancy model is a virtual cluster model. It provides strong isolation among tenants. But the difference than the previous multi-tenant virtual cluster in working group is in our implementation, it's one control plane. We do not deploy like a separate control plane for each tenant. And for the tenants, for each tenant, it's pretty transparent. They are still using existing Kubernetes API and the Kubernetes tools to interact, to share this one physical cluster. And they can also manage their tenant using the existing APIs. For example, if a tenant admin wants to do some authorization work, he can still use this cluster rule binding, rule binding, or quota, all these existing familiar ideas. All these existing familiar API objects. But all these API objects is transparently limited to the tenant scope. So if a tenant admin creates a cluster rule, that cluster rule only applies to that tenant. It won't impact the other tenants on this physical cluster. So the four key design principles in our design is we first provide this strong isolation and this autonomy, which means tenant admin can manage its own tenant without going to cluster admin every time. And also the backward compatible. All the APIs are backward compatible. The last one is the manageability. We provide some cross-tenant like a CRD sharing mechanism to provide manageability. This is an overview. The most fundamental concept is a tenant space. We introduce a tenant space in API server. So each tenant owns a tenant space. And in that tenant space, he can have all the existing resource hierarchy. We also have a system tenant space. And in the system tenant space, there's a new object type called tenant. Whenever you create a tenant object, the tenant controller kicks in and initializes the tenant space for that tenant. And in that tenant space, we initialize with this per tenant like a default namespace or kubesystem namespace or any other default objects. And this tenant space will look like just like the whole API server to that tenant. Since we added the tenant space.
Hey, Yoni, just one quick question. So is
Sure.
there a one-to-one mapping between the tenant and the space?
I'm sorry, I didn't get the question. Can you repeat?
Yeah, is there a one-to-one mapping between the tenant and the space?
Is there you mean is there
like one-to-one mapping? Yeah, you know, each tenant corresponds to a single space.
Yes. Well, this tenant object is a one-to-one mapping to the actual tenant space. When you create this object, tenant controller watches it and initialize the tenant space and creates all the default objects in the tenant space. When this object is deleted, this tenant space will also be deleted.
Okay, thank you.
Since we introduced tenant space, the internal URL object URL has been changed. If we expose this URL directly into customers, it will break all the backward compatibility, right? So we introduced a new feature called it's called short path. The idea is customer can still use the same legacy URL to access a resource, but we will transparently resolve it and change it to the internal full path. So here you can see there are two tenants. There are two users from two different tenants. They are using same URL to access the object, but each of them get their own copy. It's kind of totally transparent and isolated. And for the access control, we extend the current authentication mechanism. We still support all the authenticators. It's just that for each authenticator, we add a new field called talent in the corresponding file or the token. So after the authentication step, we have now for an incoming request, we have the talent information in addition to the original username and group information. For the authorization, we also support all existing authorizers. Actually, there isn't much change. We just add several rules to enforce the talent isolation. For now, system talent, a system talent user can access any space, and a regular talent user can only access its own space. That's the kind of the talent isolation rule that we added into the authorization. And after this step, it's all the original authorization rule. The authorizer checks the like the ABAC or ABAC configuration to do the original authorization check inside the space. So it's not a big change. It's just some extra check in front of the current authorization check.
I have a quick question. This is
Sure.
if you can go back one slide. In terms of auditing, because some customer would require that we provide,
Yes.
Have you seen any objection to this mapping? Internal
we still preserve all the capability for auditing, because before we convert to full path, we have all the original information, like where the request comes from, what's the user identity or credential associated with the request, what's the original request URL. All the information is still there. It didn't lose any information.
And auditing is still available then?
Yes, it's still available. Yes.
Okay, thank you.
That's okay.
Hey, Xiaoning.
Yes.
This is Jim. I had so I think for a lot of these things you're describing to insert, for example, like the tenant information into metadata, etc. Do you have some information on how exactly, like in terms of the Kubernetes modifications underneath? I think the main question I have is, are these done as custom resources and extensions to Kubernetes, or are these modifications in some of the core Kubernetes components itself?
Yeah, this is a very good question. In the beginning of the project, we also thought about implementing the whole solution using some decoupled approaches like CRDs. But after some investigation, we find it very difficult to provide a completed or strong isolation with only the CRDs. Let me give some examples. Let's say in order to support this backward compatibility, we have to change the endpoint resolution codes in the API server. That part is very difficult to implement as a CRD. You basically cannot change the internal logic with CRD. And also for some convenience, we want to have this talent field as a part of metadata. So it's kind of more consistent for any time for you to recognize which object belongs to which tenant space, right? And this is also very difficult to be achieved through the CRD. Of course, we can say we use annotation something, but this will kind of, from design perspective, it looks like not a very good option.
True.
So honestly, with this solution, I think the one challenge is there are some in-tree or kernel code changes. I expect this will be a kind of difficult discussion if we want to upstream.
Right, and I think that's so obviously what you've achieved is fantastic, right? This gives, like, from a user experience perspective, this is everything you would expect from a multi-tenant system.
Yes. And it's also a kind of built-in multi-tenancy mechanism.
Right.
It's native mechanism.
Right. So, but the main question, of course, which I think, which is interesting to discuss, is like how. So, are you thinking of this as just a custom Kubernetes offering, or is the plan to try and propose some of this to make it into upstream changes, or what are your thoughts?
First, the Arktos itself is a standalone project. We will continue our course to add new features and offer to some customers for which requires multi-tenant capable orchestration system. And in the meanwhile, as I mentioned earlier, I'd be happy to work with multi-tenancy working group to upstream if the community is willing to accept this kind of changes. But I guess this will be a kind of long-term effort.
Right.
Have you presented this to sig-auth or?
No, not yet, because the working group is a cross-sig entry point, right? So I'd like to start with multi-tenancy working group to see what's.
Yeah, I think it makes sense for.
Yeah.
I think it makes sense for us to talk about whether we should move on to the SIGs with this suggestion.
I think the key thing would be, in the past, whenever the API machinery group came in, they seem to indicate that if a new project was initiated within API machinery to do all of this, it would have to go through sort of the API machinery.
Yeah, I guess so. Yeah.
Have you had at least informal discussions with them outside, like if they would be willing to collaborate? Or
I haven't studied yet because I was busy on the project, Arktos project itself, and I just started reaching out to you guys.
Now, this is very cool stuff. It's exactly what multi-tenancy theoretically should be. But
yeah, I think I imagine if we design Kubernetes from beginning, we should have this, right? It should be like this way. Yeah.
Can I ask a?
Go ahead, Adrian.
Yeah, is there any reason why you called the top level division tenants and not spaces? And the reason I ask this is that there are many different definitions of the word tenancy, and you can have subtenants and producers and consumers in a SaaS context. And so the term tenant, I think, has often been caused a lot of confusion. So yes. Why call it tenants and not spaces?
Yeah, I also briefly mentioned this in my last talk. It was totally a historical reason. Historical reason. Okay. I would change it to space to make it clear, because we want to clear differentiation between the subject, user subject, and the resource object. If we call it tenant, it's confusing. But due to this some historical coding reason.
So yeah, so if we wanted to upstream this, it could be that could be improved.
Yeah, if you read our design docs, you will see in the updated design doc use the space term, but in the code it's still called tenant.
And the other question that I had is so I assume you've deployed this internally?
Oh yes, for sharing between our teams.
And sorry, I apologize if I asked this 2 weeks ago, but my memory is faded a little bit. I'll write down the answer this time. But what are the main reasons that you see people wanting to use a space? Is it to create their own CRDs, and if so, why? Are they developing new CRDs, or are they just installing operators? And then the other question I had is, if it's not CRDs, what is it? Because I think that the main hurdle that we would have in trying to upstream this is making the case that there's a strong need that can't be met in some other way.
Oh, So space is actually a very generic mechanism in our design. It's not only for CID. Let's
Yeah,
say,
no, I understand.
let's say you have two teams in the company, and they share a physical cluster. But each team want to create their namespaces and objects. They don't want to worry about this potential naming conflicts or the authorization rules. So
if I can just clarify, I understand what the features are. Basically, anything that's currently cluster scoped is space scoped, and so can be duplicated. So not just CRDs, but also namespaces, webhooks,
yes, everything.
Cluster roles, everything. So I understand what can now be divided by tenant. What I'm asking is, in your experience, what have been the main drivers for people wanting to use this feature? So not what can be done, but what is done.
Yes, I see. In first, our current deployment is pretty limited. It's only sharing. It's only shared among several small teams. We haven't had any large scale deployments in the real production yet. So
okay,
based on this limited experience, my observation is the biggest driving force is this a clean resource view and management. They don't want to see anything resource managed by other teams getting into their view. So they want to have a kind of very clean view only about the resource objects and everything else deployed by their team. That's our current use case.
And I take it that that includes what that implies to me, because today you get that within a namespace. What that implies to me is that they are deploying each team is deploying either multiple namespaces or multiple non-namespaced objects. Is that correct?
Yes, each team creates their own namespace, multiple namespace. They don't want to be limited into one namespace, because each team have their multiple different objects. Multiple projects, multiple users.
Hey, Xiaoning, can I add a few words here?
Sure.
Yeah,
Sure.
actually, Adrian, if you look into our design doc, you can see that Arktos is a project that we are working, try to make Kubernetes to be available in a big public form with very good scalability. So once we think about public platform, then we would like to have a strong isolation between different tenants, because different tenants, there are no trust. That's one scenario that we are considering.
So this is so in a zero trust environment, who is running the cluster? Is it a platform team within one company, or is this supposed to be like a kind of Kubernetes as a service provider?
It can
a cloud
be two,
provider.
Yeah, it can be two companies, like, right? So there is no trust between two companies. Actually,
okay.
The one company should not know the existence of another company is using this platform. That's the zero trust scenario that we are considering for this strong multi-tenancy.
Okay, and so that makes sense. And then in that case, so virtual clusters, so just to compare and contrast, the difference is that virtual clusters is going to use somewhat more resources. Is that correct, to run the additional copies of the API server? Is that the main difference between the two? Because it sounds like they're kind of addressing a similar problem space.
So you are comparing this to the other more virtual cluster project, right? Is that right?
Yeah, the one that Faye and
Yeah. I think
okay.
I think one of the differences is this resource consumption. The other difference is with this design, we are able to do some cross-tenant sharing, coordination, etc.
Okay, so that's okay. So one scenario is zero trust, zero sharing.
Yes.
Which sorry, what was your name? The other person who just spoke up?
Me. I'm Xiaoning.
Somebody else just.
You are talking about me, Chen.
Oh, hi.
Yeah. Okay.
So in one scenario, it is basically this is Kubernetes as a service. The different tenants have absolutely no visibility into each other, and so that would compare closely to something like virtual clusters, but with lower resource utilization. In the other scenario, you want to allow some amount of sharing between the two. And so in that case, it's more likely that this isn't really Kubernetes as a service. This is probably Kubernetes being run within a single organization, but the different teams just don't want to deal with each other unless, and they want it to be opt-in that they deal with each other. So they want multiple namespaces. They want possibly, so it sounds like mainly multiple namespaces was the key driver?
Not just multi-namespace, actually all the resources for a tenant is totally isolated from another one. So namespace, of course, is an important type, like pods, CRD, as you mentioned just now, everything, like even persist, like a PVC, then you just name it.
Yeah, because there are also some non-namespace scoped resources.
How do you handle nodes again? Sorry, again, I forget if you mentioned that last week.
Nodes in the first, depending on different deployment situation. In the for public cloud or kind of private cloud situation, our nodes object are still created in the system space.
Right.
But we do see some.
So most people shouldn't have permission to view what's on a node, because if they did, they would be able to see, or sorry, I guess that if you look at what's on a node, you'll be filtered into your own space. So you'll only see pods from your own space in a node?
We haven't done that part yet. For now,
okay.
a regular tenant can only see the node name from like some pod objects properties, but he cannot actually query the actual node object.
I see. Okay.
But in some, we do see some requests from edge scenario, the edge computing scenario. They probably want to enable some per tenant nodes. That's something we don't have detail yet, but we see some feedbacks from other teams.
Xiaoning, I'm sure you said this last time, but I've forgotten. Can the individual spaces have independent CNIs, or does have to share it?
Yes, they can have independent CIs. So basically, each tenant space can have their own I'm sorry, you mean CI or CRD?
CNI.
CNI. Okay, or CNI. CNI is now, it's not a per space stuff. It's network.
So it'll be a single shared CNI provider?
It depends. We support, we introduce a new network object, as I mentioned here.
Right.
I didn't, yeah, I think.
But the actual CNI provider is a common one that happens.
Yes, because we introduce a new object network to encapsulate, to abstract and isolate the network. CNI is associated with the type of this network object. Let's say, if you create a network object type, network object, and the type is like the AWS VPC, then you need to deploy a AWS VPC CNI accordingly. If it's the network type is neutron, then it's backed by OpenStack neutron, and you need to deploy the neutron CNI accordingly. So it's associated with this network type instead of the workspace. Workspace are just instead of space. Space are just like workloads to the network.
So the routing between the isolated IP space, which is defined in each network, that routing will be taken care by the CNI, right?
As Chen just mentioned, the public cloud scenario is a very important scenario we started with. So in our design, those networks are totally isolated. You cannot do cross network traffic unless you use public EIP. I think that's also the form of the current VPC in public cloud. Unless you enable VPC peering, you cannot do inter-VPC communication.
Okay.
Did you mostly borrow this from sort of this kind of architecture from essentially from OpenStack multi-tenancy and projects?
No. Yeah, I don't see much similarity between this and OpenStack and multi-tenancy.
Okay.
I have some questions.
Sure.
I have two questions. The first is about sharing the control plane. I really like the design, but is there any concerns about sort of like a noisy neighbor type problem?
Yes.
There's just an example, like one object in Kubernetes I've been working with recently is a priority class object. And so it's cluster wide and it influences sort of the scheduling of pods. And you can imagine a scenario where one tenant is making a pod in his space with maybe like an extremely high priority class that's above the priority of the, kube system pods. And then if the node that those pods are running on, turns over, the scheduling of that tenant's pod could potentially come ahead of the system pods. As an example of a scenario.
Yes. That's our kind of features planned features like this tenant level usage, performance isolation, and rate limiting to isolate the performance of among multiple tenants to prevent any tenant to from abusing this shared control plane. And also for scheduler, we have a tenancy fairness scheduling plan, but we don't have time to cover that part yet.
Okay, cool. But there's no way for a tenant in a space to influence sort of the master components in any way in this design.
Yes, once we implement this per tenant level, performance isolation.
Okay, cool. Thanks. And the other question I have is like in this system, you're envisioning the tenant as a user, but what if you think about it as an operator is a tenant? And I want to install 10 operators, so I want each operator to have its own tenancy model. Is that something that is entirely orthogonal to this project, or?
By operator, sorry, you mean the SIE is this kind of humans or the CRD operator program?
CRD operators, yeah, like controllers.
I'm not sure if this slides answer your question. We basically support each tenant to install their own CRD and operate independently. So tenant A install the CRD operator. It won't impact others, but we also support shared CRDs.
Right.
But Daniel, what do you mean when you said like different operators have different tenancy models? Do you mean like different instances of the same operator but in smaller scopes? Or do you mean operators that could somehow conflict with each other, or just like completely orthogonal operators?
Yeah, I mean, like the first thing you said, for example, like some operators want to watch all namespaces, some operators want to watch one namespace. Like conceptually, this is a picture of users installing operators in their space, which makes sense.
Yeah.
And if you're working on a system that is installing operators for the user on behalf of the users, then you think about the operators themselves as potentially being like tenants in the system. So I'll just bring that up as a discussion.
Yeah. Here in the left side, you can see, let's say 3 tenants that each install different CRD operator. This CRD operator, you can just run the existing operator binary, no code change. And when that, in your example, let's say operator A wants to list all namespace. Operator B only lists some partial namespace, but they are totally independent. They see different namespace. They are not interacting with each other.
Daniel, you work on operators, correct?
Yes.
You're at Red Hat?
Yes.
Yeah. How often do you see this case where a lot of different tenants within the same cluster want to run different copies of this, or different versions perhaps, of the same operator, and what is the driver behind that?
So one of the drivers is actually relevant to the crossplane presentation we had, where people are running these operators are designed to do different things on cloud providers, like outside of the cluster, and they kind of want to run multiple versions of the same operator for different teams, like different IAM accounts or whatever for each operator. That's like a classic scenario where it's like, I want multiple copies of the same thing for that reason. So that's one model.
And why do they want different versions? Just like the teams all installed it independently and the central administrator hasn't bothered to take over the admin yet, and so they're all just upgrading on their own schedule, something like that?
Well, I think it's like, from what I understand, like the way a lot of these like operators, like the AWS and the GCP ones, are like, they have like I think the permissions are scoped to one team or one user. So like if you're in a multi-tenancy environment, everyone can share the same AWS operator, for example. Like
so they're not different versions there, but they're different instances, for example.
Yes, different instances. Different versions. Well, people upgrade them, which is a different problem. But that's also something that some people want to move faster or whatever than others. Some teams want to have the latest and others don't, or something.
Okay. So yeah, you could, if it were rewritten properly, and if they all agreed to use the same version, they could all share the same CRD, and then all run in their own namespaces with their own service accounts with different permissions, correct? But then upgrading would be.
I think that example is like this fits with the system CRD like that we have here like quite nicely, where it is essentially the same operator.
Right.
But that's asking the operator author then to reinvent that the operator sort of a little bit.
Yes, I would agree with that. I guess so. What I'm my thought about this proposal, and I think I may have mentioned this last week, is that there's a lot of complexity, and it results in a very large change in, for example, like the attack surface of the API server, I think. Or sorry, not. There's kind of like an implicit promise that the spaces are fully isolated, a promise that's never really been there within the API server before. And so that's going to be challenging, and it does affect the behavior of a very, very large number of components. So there's going to be a lot of complexity if we want to upstream this. And so what I'm trying to understand, and this is behind all of my questions, is what's the magnitude of the gains that we're going to get as a result of this? If it's going to be, well, some operators who would previously have had to think about how one CRD is shared between multiple instances, they no longer need to think about that. That might not be very motivating, given that, for example, the authors of every cluster level component in Kubernetes now needs to think about this concept. So you've shifted a lot of that work to a group of different people who might not be willing to accept it. So that's really what I'm getting at behind all of these questions. I'm asking, like, how would we, if we don't have spaces, how would we do all of these things today? So I can understand, like, what's the relative gain that we're going to get from introducing these new features?
I just want to say that question makes a lot of sense. And one thing is just that you have operators that depend on other operators, and that's where the problem gets more complex. Because a lot of operators require certain APIs or CRDs that other operators are providing, and so that's where you get a lot of the complexities. Like you get a jumbled web of CRDs basically, and then upgrading that, it becomes much more complicated. Dependency resolution becomes complicated.
What's the complication in upgrading it? Because in theory, when you update a CRD, it's usually supposed to be backwards compatible. I guess in practice, do you see that doesn't happen, or is it something different?
Yes, I mean, like if you update the CRD and you're not doing it safely, you can basically break the CR, break the cluster. In theory, yes, they can be backwards compatible, but a lot of operator authors, like the best written operators are backwards compatible in theory, but in practice, I couldn't really say that. It's still pretty, yeah.
I want to I want to quickly add something. Regarding the question, what's the driver for this kind of change, right? In our vision, the CRD is just a small part. Our overall vision is that we want to enable multiple organizations to safely and easily share the same physical cluster. And there can be different scenarios. One scenario is a cloud provider can provide the virtual Kubernetes cluster service to untrusted public cloud users. That's for public cloud scenario. The other scenario is private cloud. Within one company, you have different teams and that don't want to deploy different physical Kubernetes clusters and operate, maintain it. They just want to share a large physical cluster. First, to share a large global resource pool instead of statically partition the resource. And the second, they want to have just one group to maintain, to operate the infrastructure instead of each team had to maintain and operate their own infrastructure. That's our kind of overall vision. CRD is only a small part of this the overall.
I see. Yeah, which gets into the conversation we were going to have with Rudolfo, I believe his name is.
Hey, Xiaoling, this is Fei. Yeah, I got a couple of questions. So the first question is you were mentioning that there was some cross-tenant collaboration that can be done in this model. You further explain, just give us a case. What is the case that two tenants wants to collaborate?
One of the cases that we already discussed is we want to enable this shared CRD, right? So it's common to have some system level CRD resource. For example, now some storage like Rook or some networking solution, they are also implemented as CRD. And for all the tenants on our same cluster, they're actually very likely they all need this CRD. So the first use case is that we want to share CRD among tenants for some special system CRDs. And the second, we are currently thinking about enable optional cross-tenant access. Let's say tenant A, you create still a cluster rule binding in an object, but in the cluster rule binding, you specify some resource available to users from another tenant. It's like a friend class in C++, right? So this is a optional cross-tenant resource sharing.
Okay, so I understand. So system CRD is kind of, so in current design, it is visible by all tenants or just
yes. It's kind of you first system cluster operators first deploy this CRD in system space and test it. After it's tested and working fine, it can apply a tag, a special annotation, and then it will kind of be published. I mean, by publish, I mean it's virtual. In fact, it will appear in all the tenant space immediately.
Okay, so you still kind of do a kind of copy because
no, it's no copy because what we do actually is when you query a tenant space, we combine the resource under this tenant space and also the resource in system space with that special annotation. So it's kind of dynamic merge. We don't copy this.
I got it. Okay, so that's good. So another question is, so if you are saying that each tenant can only see no name but no object, that may cause problem for scheduling, right? Because as I understand, you are still using just one scheduler. It's not per tenant scheduler, right?
Yes, scheduler sharing. Yeah.
So then if people want to do the affinity, like for instance, if this pod needs GPU and only the nodes with special label that has GPU enabled, if the people doesn't see node object, how would that work? Or
yeah, that's something we have been thinking about. One, currently we lean forward to a solution that it's kind of the operator, the cluster operator publishes some well-known or supported node selectors you can use, but regular user you don't see the actual nodes. It's like you visit the cluster website or documentation. It tells you what kind of labels, like the GPU we just mentioned, are supported on this cluster. This you can use in your pod node select, but you don't need to query the actual node objects.
Okay, so okay, I see.
The overall thought is that the infrastructure is maintained by the operators, and especially in public cloud scenario, it probably won't be exposed to the end user.
I see. So then another one is, I think maybe a little bit difficult, which is the webhook. So for webhook, there's no way you do tenant webhook, in my opinion. Or you guys really did that?
We already have some investigation on that part, but unfortunately, I don't recall the details because I didn't have time to go through that part detail. But if we are interested, can you send a mail to me? I will include Peng who investigate that part.
Oh. Yeah, because webhook is on the critical, is on the hard creation API server. That first, that is a class scope object. Second, it is I don't see this very easy to say only apply the webhook selectively based on the tenants. But
you mean the sorry, you mean the webhook of the authorization?
And disallow the tenant to install webhooks. So say that is disallowed. But if you really want to open it, that would be a little bit difficult, in my opinion, because unless you significantly change that code path.
I think we investigated some of that for authorization, but I'm not sure if we covered all you talk about. I think we can follow up offline if we can also add more, look more into that part.
So Xiaoning, going back to governance, how do you see this going forward? Let's say that the upstream Kubernetes community decides to not accept this. Will you be moving Arktos along to new Kubernetes versions independently, or you're on a slightly older version of Kubernetes currently?
Yes. We haven't decided when we can upgrade to the latest version because, as you see, we made some kind of entry changes. It will take some time for us to upgrade. But Arktos itself definitely will be kind of move forward as a standalone project, and we, regardless Kubernetes community accept this or not. In fact, Arktos itself has a much broader vision than the multi-tenant itself. We are working on different areas. It's kind of targeted for a larger scale cloud infrastructure supporting both VMs and containers, and also do some intelligent scheduling among cloud and edge. So it's kind of a larger part than the multi-tenancy.
So the multi-tenancy extensions, though, are those restricted to the API server, or are there other Kubernetes components you had to update as well?
We have to update some. We have to update some other components like this scheduler or Kubernetes controllers. But all the changes are actually very similar. It's more like a copy-paste change because for all this CIUD or list watch, we just need to add a new parameter, the talent. And we already changed like 15 controllers. Basically, one person can change 1 or 2 controllers, maybe 3 controllers a week. It's very fast. And client Go, we need to make some changes. But we are based on the 115 RC version. So the client Go still doesn't support this explicit concept parameter. With the new version of client Go, it already has, I think it already has this context parameter. It will be much easier for us to change. The code change should be much reduced if we have that explicit context parameter.
So have you thought about, how to do the real upgrading? Because I see this really challenging. If you want to upgrade a kind of standard Kubernetes to this Arktos cluster.
Yes. Oh, sorry. You mean code change or
the just I already have a Kubernetes cluster. I want to switch to Arktos clusters. I see that is really challenging because
if you want, yes, any kind of this live migration or upgrading is change right here. The good thing is our change is transparent to the client side. So that I think it will give us some kind of advantage.
Yeah, I worry more about like all the metadata like etcd. So how
yes.
how do we do that? Yeah, that's my biggest worry actually.
I think you wouldn't upgrade an existing cluster to this. You would upgrade you would port all the apps over, and they should work transparently, right? There isn't a use case to take an existing Kubernetes cluster and transform it into this one. But you could have all the applications on an existing cluster pretty much transparently move over to this kind of a cluster. So that's really the more important thing. That
yeah, that's the assumption that people, you know, would accept the option that recreate everything. But I would say I see a lot of cases, people just say, don't change anything. Don't even make my pod down. Do all the things transparently, otherwise don't do it.
We don't require, I mean, if we suppose this live migration, we don't require customer to recreate anything. Basically,
yeah, I understand, but that requires a lot of, you know, preparation. I mean, the simple thing is you ask every people recreate, then nothing needs to be done. But otherwise,
no, Fei, that's what I'm trying to clarify. Let's say if we do some live migration, all the stuff in the current etcd will be treated as the system space. We can have like the optional space keepers. So it's kind of compatible. You don't need to recreate anything. After the migration, it basically it's a cluster with only one space that is tenant space. Then you can create new tenants.
Hey, here, I would like to add some words here, because I'm the one who make change the etcd data here. So first, you don't need to worry, like all the old formats of the etcd data, we still can comprehend it. If we see it's still an old format, we know it's something belong to the system space. And then the new data, like with the tenants information inserted in the etcd key, we can also understand it. So here, what I would like to say, all the etcd data, it's backwards compatible, so it's okay.
So basically, the whole etcd, the old etcd will be just the system space.
Yeah, because like we can think of system space as the old Kubernetes cluster, and the multi-tenancy. Well, multi-tenancy, I just add some new spaces from different new tenants. So all the data, like actually there is no migration, just put them there, and our Arktos knows it.
Yeah, I mean, eventually you wouldn't want an app running in the system namespace, but if you want to take a cluster without individually porting the apps, that's what you have to do. But eventually you want the apps to run in it.
Yes, exactly.
Hi, this is Antu again. I have a question on future directions.
Okay.
You showed earlier. Not that one, the Arktos one.
You mean the other slides?
Yeah. You mentioned unified container and VM orchestration. I'm curious to hear, if possible, some of your thoughts on that.
Sorry, I didn't get the last part.
What you're thinking in that area.
Oh, we already implemented. It's I probably can. I know it's not related to the multi-tenancy topic, but I can quickly use 1 or 2 minutes to explain. It's basically currently in cloud data centers, more and more containers are running on bare metal. So we have 2 orchestration stack. One is Kubernetes based for containers. The other is the old like the VMware or the OpenStack for VMs. So our vision here is we want to extend Kubernetes to have a single orchestration stack to handle both containers and VMs. And the way we did is different than the current some approaches based add-on based approaches. We extend the pod definition. You can see this is original pod definition. You can have multiple containers. Now you have VMs. And because we extend this most fundamental object pod, and we we can reuse everything on top of that, like a replica set, deployment, jobs, and scheduling. It's one API, one scheduling, one orchestration stack. We already implement part of the functionalities, but because VM lifecycle is complicated, it's not only stopping, and rebooting VM. You have like this attach volumes, attach NIC, dynamic reconfiguration, live migration. We are still working on this advanced events and state configuration. I can also share this slides link if you guys are interested in kind of in a broader sense for Arktos.
That would be great. Thank you.
Thank you.
Are you
And,
seeing
by the way, sorry, just one. We are also actively looking for external partners and for any user cases. So if you are interested in the project, feel free to contact me and we can work together. Thank you.
Do you see customers more in the service provider space? What are your initial customers? I mean, typical use case for your initial. I think
we are targeting the use case or the scenario that is cloud provider, especially large scale cloud provider. Because we look at the current open source projects, there isn't actually a open source project qualified for large scale and multi-tenancy and this unified VM container infrastructure for large scale cloud providers. So that's why we decided to work on this the open source, to have this open source project.
Yeah, very nice.
I think we are running out of time. Maybe we can continue the discussion in the next meeting or in the email.
Yeah, I think so. I think.
Yeah, I think that sounds good. You know, I would ask that if people have any questions, maybe hit up the mailing list. And, you know, if there's any reading material for Arktos, maybe send that over the mailing list so we don't have to make you give the same presentation 3 times. But yeah, thank you. And, you know, I think that this is really raising some good questions from everyone. So it's very thought-provoking, and thank you for sharing.
Thank you for your time.